Hey everybody, welcome to Physical Science today. This is the beginning of a new unit. We're going to take notes here for a little bit. And the question that we're asking ourselves is, what is matter? Here's the first definition that you need to know right here. Atom. Okay? Atom is the smallest unit of an element that cannot be separated or broken down into simpler substances by ordinary chemical means. So in other words, ordinary chemical means does not include the atomic bomb or any nuclear weapon, because we do split atoms. And when we do split atoms, we get a lot of energy, and the relationship is this. The mass that is lost or changed or converted times the speed of light squared, that's how much energy we get. So we're not talking about that kind of thing. We're talking about what you can do in a scientific laboratory. You cannot split an atom. The word atom comes from a Greek word called atomos, and that Greek word atomos means indivisible, cannot be divided. Okay, so I'm going to fix that link. It'll be right on Moodle here in a little bit. Here's some notes kind of right out of the book. So if you want to take a second to write this down, you can. Or you can bring it in printed next time. But you're going to want to leave a little space between here, because the first thing we're going to talk about here is a substance, okay? So a substance here then is either an element or a compound, okay? And these are called pure substances. Okay, so if you look at their pictures here, this here is the periodic chart, and each symbol here on the periodic chart is an atomic symbol. Okay, so that would be a pure substance. Now, if you look at this, these are the kinds of elements that we have in the Earth's crust, for one, and also in the human body. So let's take a little look at this. What you can see is, oxygen in the human body. Oxygen in the human body is 65%, where oxygen on the Earth, and this would be like the crust is 29.5%. Most of that is in sand, silicon dioxide, I believe. Another thing that's in all human or all living things is carbon, and that when we do carbon dating, we look at carbon and the way that changes over the years. Iron is very common in the Earth's crust, where we don't have much iron in the human body, but most of it is oxygen. In fact, in reality, what is most of the human body made out of? Yeah, most of the human body is actually made out of water, or salt water, really. It's like 70 to 75%, and that's kind of typical for most living things. The Earth is covered by approximately 70% water too, which is kind of interesting that those two numbers coincide. So these are all elements. Now, go back up to the notes here. The next thing that we want to talk about is a compound. Okay, so you look here, we're talking about the compound. Okay, it's a substance with two or more elements combined in a fixed proportion. Okay, so when I asked you what is the body made out of, you said water, right? Well, water is made out of what? Do you guys know what water is made out of? What's the H2O is the chemical formula, and so that means it's hydrogen and oxygen. So if you look at your periodic chart, you can find both of those. So we've got hydrogen and oxygen here, and H2O. Now a compound it has a fixed number of elements in it all the time. So if I have water, it's always going to have this ratio, 2 hydrogens, 1 oxygen, no matter where you find it, no matter where in the whole entire universe. that you find. It'll always have this exact same ratio. Okay, so that's a compound. If we look at down our notes a little bit, here's a question. Which of the below is an element, which is a compound? Okay. Yes, thank you, chemist, for that answer. The element here is oxygen. Now, if you look at this, it's not just O, but it's O2. Do you agree with that? That is okay, because the definition of an element is it's just one type of atom. So it's just oxygen. Even though it's in a compound, it's just oxygen by itself. And then these two here are compounds. I'm sorry, I said oxygen was in a compound. I meant a molecule. These two are compounds, which means more than one type of atom. So if you look at this periodic chart here, this is something you should mark up on your own periodic chart. This hydrogen, okay, so mark this hydrogen on your own periodic chart somehow, and then this upside down L right here, I might use a little bit different. Right here, right here. This is called the diatomic molecules, or these are called the diatomic molecules. And what that means is when they are elementally alone, which means not in combination with any other things, they float around together. So we have two hydrogens together, or two nitrogens, two oxygens, two fluorines, two chlorines. This entire upside down L along with hydrogen is called diatomic molecules. Okay, so those elements are always found in groups of two, and they float around they're called diatomic molecules. The question was, what's the actual definition of a compound here? Okay, so we have a compound right here, and it's defined as a substance with two or more elements combined in a fixed proportion, which would be like water is a compound. NaCl is a compound. MgCl2 is a compound. So wherever I find this stuff, anywhere in the Earth's crust or in the universe, it will always have this fixed ratio of molecules. Otherwise, it's called a different name. It's a different compound. Okay, so we go on to our next part of the notes here. We have mixtures, okay? So if we have two or more substances that can be easily separated by physical means, they're called a mixture, okay? So before, what we were talking about up here was we were talking about substances that cannot be separated by ordinary chemical means or physical means. Now we're segueing into a substance that can be separated by physical means to form a mixture. Okay, so there's two kinds of mixtures. The first one is called heterogeneous mixture. And the word hetero means different. Okay, and the second kind of mixture is homogeneous mixture, and homo means the same. So heterogeneous is a mixture that can be easily distinguishable. So I got a little picture here for you. It says, what kind of mixture is a pizza? Yeah, this is a heterogeneous, so you can see that, there's pepperonis, peppers, all that kind of stuff. How about this? What would that be? Apple juice. Okay, is that hetero or homogeneous mixture? It's homo because it looks like one thing throughout. So that's the definition of a homogeneous mixture, is it looks like one thing. Okay, and then we have colloid here. A colloid is a special type of mixture. It's heterogeneous. Okay, so but it has larger particles that never settle out. So, we have this suspension is another type of heterogeneous mixture, but it has particles that will settle out. So muddy water is like a good example of a heterogeneous mixture, because if you've ever played in muddy water in cups or toys, and you come back the next day, you see all that sand in the bottom, right? Or if you go to the lake and you're playing close to the beach and the water gets really muddy, and then you go back later and it looks clear again, that would also be a suspension, okay? But a colloid is different. The particles are small enough that, and the interaction with the liquid that they're in is such that they never settle out, okay? So colloid, scattered light, and Tyndall effect is the name of this situation where you can see the light scattering. So if we look at the picture for the Tyndall effect here, you will see this. Here's a Tyndall effect. If we shine a beam of light into a colloid, you'll be able to see the light in the colloid. So when we study lasers in the second part of this class, we're gonna have to make a colloid mixture so you can see how the lasers are acting inside water. And then this one would be a true solution. So sometimes you can't tell if something's a colloid or a solution unless you shine light into it. So a true solution, you won't be able to see that light. It could come out the other side, but you don't see it. So it's not absorbed necessarily, but you don't see it. So here's like a better actual picture of the Tyndall effect here. And so you can see this first one is a true solution, so you can't see the beam in there. It does look like there's somewhat of a lighter area there, whether that's the glass or what it is, I'm not exactly sure. But if you didn't see any light in there at all, that would be a true 100% solution, which is hard to make and keep. Even dust from the air and stuff can settle into a solution and make it something other than 100%. But here you can see it scattering a little bit better. Right? So this one's a colloid solution. This is closer to a true solution here. And this scattering of light in a colloid is called Tyndall effect. Okay, so kind of to sum it all up here, or sum up part of what we talked about at least, we can look at how it all fits together. And this page has another structure here for you to make these connections. So you can see at the top we have atoms and molecules. Okay, and they make up all matter. Okay, and then all matter then exists as substances or mixtures. And then the substances are the things that are, they have a definite composition. So like the elements. So if you look on an atomic structure, the element here you can see it's similar throughout the whole structure. It's like, in this it looks like a crystal. And then here's another one. Here's water right here. Okay, so this is a little different. It's not rigid. This is a solid. This is a liquid. So these molecules are free to move around each other. They stay very close together like a solid. And then here's a salt crystal, which is different than both of them because this is a regular repeating pattern. We'll talk about that later. But still, the ratios are the same. Now this is a homogeneous mixture here. So this looks like one thing, but you can see that the pattern of the way that the particles are arranged here is not a rigid pattern. But they're small enough where this is going to look like one thing when you look at it. But notice that, you have 3 in a row here, you have like 5 or 6 in a row here. It's not a rigid pattern. And then so that's a homogeneous mixture. And then this one down here is the heterogeneous. So these parts, so like, if this is like salt water, then these would be the water particles here, and then this would be, well, that wouldn't be salt water, this would be like muddy water. This would be like a particle of some kind of dirt, but you can see that it's, you know, not regular, and it's not, the pieces are different sizes, so it's easier to see them, and it'll be easier to separate these things by physical means, which is something we'll talk about later. So now we're going to do a short lab on elements, compounds, and mixtures and see if you understood these notes.